Hello and welcome to Maths with Jacob. This lesson will focus on binary numbers. In our normal number system, we use the following digits: 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Our system is called the Hindu-Arabic number system, and it operates in base 10. The reason we call it base 10 is that there are 10 digits. Each number has a place value based on powers of 10. For example, consider 6538. The above number can be broken down as follows. So 6538 is 6 by 10 to the power of 3 plus 5 times 10 squared plus 3 times 10 to the power of 1 plus 8 times 10 to the 0. That's how we break it down. And 10 to the 0 actually has a value of 1. We'll see that later on, but 10 to the 0 has a value of 1. So this is like the ones column. So that 8, which is over here to the extreme right, is in the ones column. That's why that's 8 times 1. The binary system of number operates by using only two digits. They are 0 and 1. Each number has a place value based on powers of 2. For any binary number, the following columns tell us how to find the value of a binary number in Hindu-Arabic number system. So basically what we're saying is this, that with respect to a binary number, this first column on the extreme right is the ones column, because 2 to the 0 is 1. The next column, now in our normal Hindu-Arabic system, that's the tens column. But this one is the 2 to the power of 1, which is the twos column. The next column in the Hindu-Arabic number system, that's the hundreds column, or the 10 squared column. But because we're operating in the binary system, any number in this column has a value of 2 squared, which is 4, and so on. Any number in this column, whether it's a 1 or a 0, that's the value of it, that's the value in that column, and that's the value in that column. And all these numbers here are powers of 2. So let's see how an example actually works. Consider the binary number 11101. What is the value of this binary number in the Hindu-Arabic number system? Let's have a look. This is the answer. We do it this way. Now I've repeated the table for ease of reference, and these are the values in each column. Now here we have 5 digits. They're either ones or zeros because it's the binary system. Now because there are 5 digits, right, this is how we do it. 1, 2, 3, 4, 5. So the first digit, which is a 1, the value of that is 1 times 2 to the power of 4. The next one, which is this one, the value of that is 1 times 2 cubed. The value of the next one is 1 times 2 squared, which is that column. This one here is 0 times 2 to the power of 1, and this one is 1 times 2 to the power of 0, or 0. Now 1 times 2 to the power of 4 is actually 16. 1 times 2 cubed is 8. 1 times 2 squared is 4. 0 times 2 to the power of 1 is 0. And 1 times 2 to the power of 0, that's actually 1 by 1, because that's the ones column, that's 1. So this binary number here, when we add all those together, we get 29, and that's the value in the Hindu-Arabic system. So 29, that's the Hindu-Arabic number, that's the binary number. What is the value of 1010 in the Hindu-Arabic number system? So 1010, we have 4 digits. So this is how we check 1, 2, 3, 4. We have to start in that column. So that's the far left number. So this 1 is actually 1 times 2 cubed. That 0 is 0 times 2 squared. This 1 is 1 times 2 to the power of 1. And that 0 is 0 times 2 to the 0. So that gives us 8. That's a 0. That's a 2. And that's a 0. So we add all those up and we get 10. So this 10, which is the Hindu-Arabic number, that's the number in the binary system. Now we'll go the other way. Let's go from the Hindu-Arabic system back to the binary number. So we need to write 58 as the sum of individual numbers where each of these individual numbers is a power of 2. In other words, 58 has to be the sum of these numbers. Any of these numbers here, they need to be added up to give you 58. So, because we have 58, we certainly can put 32 down as one of the numbers. Now, can we put 16 down? Let's check. 32 plus 16. Yes, we can, because that doesn't equal 58 yet. So we can also add 16. We can also add 8. Okay, so let's check. 32 plus 16 is 48. Plus another 8 is 56. We only have 2 left, so that number must be 2. So the 58 is the sum of those 4 numbers, and each number is a power of 2. So the above numbers tell us which columns contain the number 1. All other columns contain the number 0. So this 32, okay, the 32 there is in this column, right? So it's actually 1 times 2 to the power of 5, because 2 to the power of 5 is 32. This 16 is in that column. So it's actually 1 times 2 to the power of 4. The 8 is in this column. So we have 1 times 2 to the power of 3. Now, the next one is a 2, which is that column. That means there's a 0 in this column. So that's 0 times 2 squared. The 2 is 1 times 2 to the power of 1. And for the last digit here, okay, it's 0 times 2 to the power of 0. So, basically, 58 will be 1, 1, 1, 0, 1, 0. So 1, 1, 1, 0, 1, 0. So that's the number in the binary system, and that's the number in the Hindu-Arabic system. So this video has introduced us to the idea of binary numbers, where we are working with powers of 2, and we've seen how we can change binary numbers into the Hindu-Arabic system, and we can also convert numbers from the Hindu-Arabic system back to binary numbers.